Hey everybody, we are going to shoot the marble launcher at 60 degrees as hard as it'll go. So before we do that, what we have to do is figure out how hard it shoots the marble, its initial velocity. So we're doing that by shooting it straight up in the air. Let's watch. Here's what we're going to do. We're going to shoot this marble launcher, we're going to shoot it up in the air, we're going to let it land, okay? And if we time it from how long it takes to go up and down, then we can calculate the initial velocity. So here we go. You can try to time it at home. All right, ready? 1, 2, 3, go. And if you couldn't see it, kids at home, you can hear it. All right, let's roll. So we calculated the time that thing was in the air, and I hope you maybe replayed that a couple of times and try to do it yourself. You should have come up with about 1.8 seconds, okay? So 1.8 seconds. That was, when we shot the marble straight up, it was in the air for 1.8 seconds, which means that if we were thinking about a marble that fell to the earth, it would only fall for 0.9 seconds. So the speed that the marble hits the ground with is equal to the speed that it was shot up into the air with. So if we can calculate what velocity something would gain if it fell for 0.9 seconds, that's how hard the marble is shot. So I'm asking you right now, what formula will I use? I know that we're on Earth, and the acceleration on Earth is 9.8 meters per second per second. And I know that the marble will go either up or down for 0.9 seconds. So what formula would I use? That's right. Use A is equal to delta V over T. And then now, what velocity will we get from this? What velocity will we get? We'll get 9.8 times 0.9, and that will equal the change in velocity. And one of the velocities is 0. So the change in velocity is the velocity. So I'm going to do that with my calculator. 9.8 times 0.9, 8.82. So we'll go 8.8 meters per second. That's the velocity with which the marble launcher shoots a marble when it's on its maximum setting. So let's go from there. 8.8 meters per second. You need to be drawing this on a big sheet of paper. If you're not doing that, you're not trying hard enough. We're going to shoot this bad boy. That's not tall enough. We're going to shoot it at 60 degrees out there. That looks like about 60 degrees. It's probably even not quite steep enough. We're going to say it's 60 degrees. 8.8 meters per second is the launch velocity. Now, that time that we had the marble in the air, that 1.8 seconds total, that's gone. Because that was if the marble was shot straight up. Now we're shooting the marble at 60 degrees. So we need to figure out, that will be just like shooting a marble slightly slower straight up. Does that make sense? Okay. What trig function am I going to use to compare the velocity here to the velocity here? That's right, I'm going to use sine. The sine of 60 is going to be equal to the opposite side, that's this side, over the hypotenuse, which is 8.8. So I'm going to take my calculator. 8.8 times 60 sine equals. So if we shot it straight up in the air, that would be like shooting it, that's funny, like shooting it at 7.6 meters per second. Okay? Now I'm going to ask you, if I shot something up in the air at 7.6 meters per second on the planet Earth, how long would it take it to get to the top and stop? We're going to use this formula. A is equal to delta V over T. And tell me how long it would take the marble to go up. All right, good. You end up with 9.8 that's the acceleration, is equal to 7.6 over t. We got to solve for that t, which means we switch it with the 9.8. 7.6 divided by 9.8. So I still have my old 7.6 number in there. Divided by 9.8 equals 0.78. So 0.78 seconds up. Takes it 0.78 seconds to get to the top. Now let's think. If the marble is flying through the air, it goes both up and down. So the amount of time that the marble is traveling sideways is going to be 0.78 seconds times 2. Correct? So I'm going to hit times 2 for my 0.78 seconds. And I get 1.56. So the total sideways time is 1.56 seconds. And it's going to travel at a certain velocity. And that's going to tell us how far away this marble should land. All right? So how am I going to find this velocity? Well, I already have this trig function, this velocity on this vector, the velocity on this vector, and right here. So I can use either cosine, which is the adjacent over hypotenuse, or I could use, if I kept all my decimals, I could use tangent 60 opposite over adjacent. I'm going to use cosine. So tell me, what's this velocity if you cosine this angle and this being the hypotenuse? All right? Cosine 60 equals the adjacent side over the hypotenuse, which is 8.8. So I'm going to say 60 cos times 8.8. 60 cosine times 8.8 equals 4.4 meters per second is the horizontal velocity. And this thing, if we're thinking about the shadow going across the ground, it will go across the ground for 1.56 seconds. Because if you look, this is the shadow and this is the marble. Does that make sense? So 4.4 times 1.56 seconds. So we're going at 4.4 meters per second for 1.56 seconds. And we're going to expect this thing to land 6.9 meters away. Let's go out and actually try to do it. All right. Yeah, well, kids, I'm already rolling here. Kids, we're going to fire this thing. Now, we haven't aimed it yet. We're going to let you go ahead and see the mistakes. You can see what you think. I'm going to try to get the whole thing in here. And Mr. Spears will let it rip when you're ready to go. He's trying to aim it. Trial number 1, 2, 1. Very, very close. I like that. Kids, here we go again. Second try. We're consistently coming up about 1 meter short. All right, kids, we remeasured it because we came up about 1 meter short every time, but we didn't move it. Our measurement was correct. We're going to try it again, see what happens.
Final try. 3, 2, 1.
All right, we're just coming up about 1 meter short. All right, kids, here's my best explanation as to why we're coming up short. If you look, Mr. Spears is going to set the marble in there. See how the marble is sitting on the bottom of the tube here, okay? And there's a gap on the top. Now, when we flip this guy to 90 degrees, the marble's sitting right in the middle, okay? And then the plunger is hitting the middle of the marble. So when we shoot it straight up in the air, we're getting a little higher velocity than we are when we're shooting it sideways. Now, that won't come into effect when we're shooting it on a lower setting. The difference will be small enough where we still hit the bucket. But when we're on the highest setting, it amplifies the difference in velocity when we're trying to shoot it that far. And I hope that makes sense to you. Peace out.